Good morning, students. Today we will discuss the topic Law of Conservation of Energy from Chapter 11 Work and Energy. Now, what does this law state? It states that energy neither be created nor destroyed in a process. Whether the process is chemical or physical, it doesn't matter. In any of the processes, energy cannot be created and it cannot be destroyed. It remains same, it remains conserved or constant. It is just changed from one form to another. So, its form is changed. Otherwise, overall energy remains same, constant, conserved. So, I can conclude that according to law of conservation of energy, energy neither be created nor destroyed in a process. It is just changed from one form to another. For example, burning of coal. When we burn coal in the presence of oxygen, then it produces carbon dioxide, sulfur dioxide, nitrogen dioxide. Many unburned carbon particles form smoke. Along with these substances, it produces heat and light energy. So, coal has chemical energy which on burning changes into heat and light energy. So, here energy is not destroyed. It is not created. It is just changed from one form to another. From chemical energy to heat and light energy. In the same way, when electricity is generated at hydropower plant by flowing water of river, in that case also law of conservation of energy is obeyed. How is that? See, as you know that when river water flows, that flowing water has kinetic energy due to its flow, due to its motion. Then that flowing water is obstructed by a large long dam, and then that water is stored at a height in the reservoir of the dam. So water attains a height. Due to this, it acquires potential energy. So kinetic energy of water is converted into potential energy. Then gates of dam are opened. Due to this, that stored water is made to fall downwards. So now water again starts flowing, again starts moving downward. So it again attains kinetic energy. So potential energy of water is converted into kinetic energy. This water is made to fall on turbine. Then turbine moves. So movement of turbine takes place. So we can say that now turbine gains kinetic energy. From where kinetic energy of falling water is converted into kinetic energy of turbine. Due to the movement of the turbine, shaft of the generator turns, rotates. So, kinetic energy of the turbine is converted into kinetic energy of the shaft of the generator. As a result, electricity is produced. So, kinetic energy of the shaft of the generator is converted into electrical energy. So, during entire process, is any energy created or destroyed? Not at all. Energy is not created and not destroyed in this process. Energy is just changed from one form to another form. So overall energy remains same, remains constant or conserved. This is called law of conservation of energy. One more example. When we hit a target with the help of arrow and bow, then how does this happen? How the elastic thread to increase its position. Due to increase in position, due to change in position, that elastic thread and arrow gain potential energy. After that, we release arrow from our hand. Then what happens? It comes into motion from that position. So now it acquires kinetic energy. So potential energy is converted into kinetic energy. And when this arrow hits the target, it produces sound and heat. So kinetic energy of the arrow is converted into heat and sound energy. So first of all, both arrow and thread acquire potential energy due to increase in position. Then after releasing arrow from our hand, it acquires kinetic energy due to motion, and on hitting the target, its kinetic energy is converted into heat and sound energy. So here energy is not created, energy is not destroyed, it is just changed from one form to another. This is law of conservation of energy. How is law of conservation of energy obeyed in the case of a freely falling object? You can see in the figure, there is an object having mass m, is kept at a certain height from the ground. Due to this height or higher position, it has maximum potential energy, because potential energy EP is equal to mgh. So here it has a maximum height, so it has maximum potential energy. But this object is at rest, so it is not moving, so it has zero velocity. So kinetic energy equal to half mv square, where v is 0. So kinetic energy is 0. So at this height, it has maximum potential energy, but minimum, or I can say zero kinetic energy. When this object is released from this height, obviously it moves towards earth, towards ground, under the influence of gravitational force only. So this object is said to be under free fall. So during this free fall, its height decreases continuously. As the height decreases, its potential energy also decreases. With the decrease in height, potential energy decreases, but here motion of the object, velocity of the object keeps on increasing. That is why motion or velocity keep on increasing, so its kinetic energy keeps on increasing. So potential energy decreases, kinetic energy increases. Or I can say that potential energy is continuously getting converted into kinetic energy. Now, at halfway down or at half path or route, height becomes half of the former value. So potential energy also becomes half of the former value. So half of the potential energy is reduced, and that is converted into kinetic energy. So here at this midpoint of the path, potential energy becomes equal to kinetic energy. Now, below this half path, its height becomes less than half of its former value. So, potential energy becomes less than half of its original value, and that reducing potential energy is converted into kinetic energy. So, here potential energy becomes less than kinetic energy. Now, when this object is nearest to the ground, at this point its height is minimum. So, height is minimum. then potential energy reaches its minimum value due to extreme decrease in the height, and that potential energy is converted into kinetic energy because of the extreme or drastic increase in the motion or velocity of the object. So potential energy is converted into kinetic energy at a point nearest to the ground. So here at this point, potential energy has minimum value due to minimum height, and kinetic energy has maximum value due to maximum velocity due to maximum increased motion. Now, when this object strikes with the ground or earth surface, then ultimately it comes to stop. It means its velocity becomes zero. So when velocity becomes zero, then kinetic energy also becomes zero. So what happened to its kinetic energy? See, when object strikes with the ground or earth surface, then its kinetic energy becomes zero because its velocity becomes zero because it stops on striking with the ground. But its kinetic energy is not destroyed. It is converted into heat and sound energy which produce when object strikes with the ground. So here in this case, potential energy converted into kinetic energy, and then kinetic energy is finally converted into heat and sound energy. So no energy is created or no energy is destroyed. Energy remains constant, same, conserved, only its form is changed from potential to kinetic to heat and sound energy. So this is law of conservation of energy. So whatever the process is, it can be chemical process, it can be physical process. In any of the processes, energy neither be created nor destroyed. It remains same, conserved, constant. Only its form is changed. So this is all about law of conservation of energy. In all these examples, you have observed, you have learned that energy neither be created nor destroyed in any of the processes. It is just change from one form to another. Now, next topic is power. You must have heard this term many a times in your day-to-day life. Do you have any idea regarding power? Power, it is the rate of doing work. Power is the rate of doing work. See, if rate of doing work is more, then power is more. If rate of doing work is less, then power is less. Rate refers to time. It means in a particular time, how much work is done by object. That is its power. If in a particular time, object is doing less work, then its power is less. And in the same time, if object is doing more work, its power is more. So, power is the rate of doing work. Means in a particular time, how much work it is doing or how much work it has done. If it has done more work in a particular time, then its rate of doing work is more, its power is more. If it is doing less work in particular time, then its rate of doing work is less, its power is less. So this is all about power. From the definition, we can derive its formula. Power is the rate of doing work. Means in a particular time, how much work is done by the object or how much work it is doing. this is the formula of power. P is equal to W upon T or E upon T. Now SI unit of power, it can be derived from the formula only. Formula of power is work upon time or energy consumed upon time. So SI unit of power is equal to, in formula, here is work and here is energy consumed. Both are same. So both have same SI units, that is joule. Upon time, SI unit of time is second. So SI unit of power is joule per second, denoted with capital J upon small s. Joule per second is equal to watt, denoted with capital W. So what have we learned about the SI unit of power? SI unit of power is joule per second or watt. So overall we can say that SI unit of power is watt, which is equal to joule per second. Now if I say power of a device is 1 watt, then what does it mean? It means it is equal to 1 joule upon 1 second. So it shows that object is doing 1 joule work in 1 second. So that object or device is doing 1 joule work in 1 second. Then the power is 1 joule upon 1 second, that is 1 watt. Let me tell you one thing. In our houses, industries, factories, hospitals, we use plenty of electronic devices, and that devices have high or large powers. So they have high or large values of power. So to express and measure their high powers, we use a big commercial unit of power known as kilowatt, kW. 1 kilowatt is equal to 1000 watt. So this is the big commercial unit of power which we use to measure and express the high or large values of power of electronic devices and other devices also. Now, what do you mean by average power? To understand this, let us take an example. In this example, object has done 1 joule work in first 1 second, then 2 joules work in next 1 second, and then finally 4 joules work in last 1 second. Here, rate of doing work of the object varies or differs. So, in every case, power is different. So, if someone asks us to calculate power, then in which case do we find power? Which case we will take to calculate power? See, here power differs, power varies. So, it is not like that we calculate the power of first case or second case or third case. Power is not same. So, we cannot take or calculate power of any of the cases. Power differs, varies. So, in this example, we will calculate average power. How's that? Total work done or energy consumed will be divided by total time. This will give you the value of average power. So what is the average power? It is the total work done or energy consumed by an object divided by total time. This is called average power. So this will give you an average power or mean power by which object has done work. So from the definition we can derive the formula average power is equal to divided by means upon total time. So average power can be denoted with capital P is equal to total work done or energy consumed is denoted with W or E upon total time upon small t. So we will get the same formula which power has, that is P is equal to W upon T or E upon T. Now P is equal to, what is W or E? Here total W means work done or energy consumed is 1 joule plus 2 joule plus 4 joule. It will be equal to 7 joule upon, what is the total time here? It is 1 plus 1 plus 1, 3 seconds. 7 upon 3, it is equal to 2.33 joule per second means watt. So what is the average or mean power by which object has done work throughout? That is 2.33 watt. So far in this chapter we have learned about work, its definition, its formula, its SI unit, its types. Then we have studied about energy, its various forms, their definition, their formulae, then law of conservation of energy, and finally power. But we have not studied the formula of energy. What is the basic formula of energy? See, power is equal to work done upon time or energy consumed upon time. So P is equal to W upon T or E upon T. Take this formula, P is equal to E upon T. From this formula we can derive the basic formula of energy E. How is that? Here T is dividing E. When we will transfer it from right side to left side, it will multiply P. So we have P into T is equal to E, or we can write it as E is equal to P into T. So this is the basic formula of energy, equal to power into time. Now from this formula we can derive the SI unit of energy. Power, what is the SI unit of power? Watt. Into time, what is the SI unit of time? Second. So what is the SI unit of energy? Watt second, known as joule, denoted with capital J. So here we have derived SI unit of energy, that is joule equal to watt second. It is similar with the SI unit of work that I already told you. Now what is the commercial or big unit of energy? See, as I told you earlier that we use plenty or variety of devices or electronic devices in our houses, schools, offices, industries, factories, etc. And these electronic devices consume or use a large amount of electrical energy. So, to measure or express large amount of electrical energy, we need a big commercial unit, so that large amount of electrical energy can be measured or expressed easily, properly. Commercial unit of energy can be derived from the formula only. Formula is power into time. Now, commercial unit of power is kilowatt into commercial unit of time is hour. So, commercial unit of energy is kilowatt hour, which is commonly known as unit. So, you must have observed or noticed in your electricity bills that whatever the total amount of electrical energy is consumed by our electronic appliances, that is measured or expressed in kilowatt hour, which you call units commonly. Now, So commercial or big unit of energy is kilowatt hour, commonly known as unit. Now question is how big it is and how small it is. So we will compare both units of energy, commercial unit with the SI unit. See, 1 unit means 1 kilowatt hour. As you know that in 1 kilowatt there are 1000 watts. So in place of 1 kilowatt we can write 1000 watt. Into hour, in 1 hour there are 3600 seconds. So 1000 watt into 3600 seconds, it is equal to 36 lakh watt second. 36 lakh watt seconds can be written as 36 into 10 to the power 5 watt second is equal to joule. So in place of watt second we can write joule. So 36 into 10 to the power 5 joules. 36 into 10 to the power 5 joules can be written as 3.6 into 10 to the power 6 joules. So what we have concluded? We have concluded or inferred that 1 unit which is equal to 1 kilowatt hour, that 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. So commercial unit of energy, that is kilowatt hour or unit, consists of 3.6 into 10 to the power 6 joules. So you can see that how big it is and how small it is. So we use it often when we measure large amount of electrical energy. This is all for